Here we are going to see the analysis of bars of varying cross section. Analysis of bars of varying cross section means here in each part of the bar we have to find out stresses and also strains in the bar, and in the final step we have to find out total elongation of the bar. And see here, so here in this bar, because of varying cross section, if you suppose it, consider part 1, and first point we have to remember is when you divide the bars, the load taken by each bar is same as the given load at the ends of the bar. So that is we have to take that consideration. And here, suppose if I write the stress in part 1, and this is stress in part 1 sigma 1. From the basic definition of stress, we know stress is equals to load by area, and here the part 1 area is A1, and if we assume it is the circular cross section, it will become P by A1 is pi by 4 d1 square. And we have to find out elongation, that is delta L in part 1. So that we find out from the basic definition of Young's modulus, E1 is equals to stress in part 1 by strain in part 1. From this, if I write strain in part 1, small e1 is equals to stress in part 1 by Young's modulus of part 1 e1. So, and if I write this sigma 1 by, if I write this one, that is load by area 1, A will come down, and this is E1 is already there, and this is E1 strain in part 1. You know that strain is change in dimension by original dimension, that is change in part 1 by original length of the part 1, that is L1, and this is P by A1 and E1. And if I write this is delta L1, that will become P into L1 by A1 into E1. So this is the elongation in part 1, and a stress in part 2. In part 2, that will become the similar way. Stress in part 2 is sigma 2 is equals to P by A2, and that will be P by pi by 4 d2 square. And in the similarly, if I write strain in, or that is elongation in part 2 from the first step, that will be P into L2 by A2 into E2. And if I write the similar manner for part 3, if I write part 3, stress in part 3 will be load by area of part 3, and that will be P by pi by 4 d3 square. This is part 3, d3 we have taken, that is. And if I write elongation, that is delta L3 for part 3, that will be in a similar manner that is discussed in the part 1, part 2. That formula will be P by L3 by A3 into E3. So this is the stresses and elongations in individual part. If I want total elongation of the bar, let us add all these elongations, delta L1, delta L2, delta L3, to get the total elongation of the bar. So if I write this one, delta L is equals to delta L1 plus delta L2 plus delta L3, and that is P into L1 by A1 E1 plus P into L2 by A2 E2 plus P into L3 by A3 E3. And suppose if the bar is this composite bar is made up of every cross section is same material. So let us we can take E1 is equals to E2 is equals to E3 is equals to E. So E will be common here, and I can take P from the numerators, and E is common because it is total every cross section is of same material. So I can take P by E1 instead of E1, E2, E3. I can write only E, and that will be L1 by A1 for the part 1 plus L2 by A2 for the part 3 plus L3 by A3 for the part 3. So this formula will give total elongation of the bar. Thank you.